Hi again, this is Mr. Wakefield, and today we are going to be looking at multiplying and dividing polynomials. Okay, um, multiplying and dividing polynomials, and how is that different from adding and subtracting polynomials, and also adding and subtracting terms? Okay, we're going to get into all that. Let me jump right into an example here. We have a monomial term, in other words, being multiplied by another monomial or term, and it's completely different than when you're adding and subtracting terms. Let me give you an example that comes from a different video where we talked about adding and subtracting terms. Okay, you have this polynomial right here, and of course a polynomial means a bunch of terms being added and subtracted. Okay, when you have terms being added and subtracted, you can combine like terms, but when you do combine like terms, as you know, the variable part has to be the same in order to combine it. Okay, and then it stays the same. X squared stays the same. However, with multiplying polynomials, the like terms, they don't need to be like terms. Okay, so being like terms is not required. You can multiply any two terms you want, whether they're like terms or not. And on the other thing too is that since they don't need to be like terms, remember when we said that when you have like terms, the variable part of the term stays the same. Well, they're not even the same when they're not like terms, so there's not that requirement either. What you do instead, and it mentions it a little bit up here, is when you're multiplying two terms together, and this is clearly multiplication, again, because when you have two brackets smushed together like that, that means multiplication. What you do is you multiply the coefficients like it says up here. The 11 and the negative 3 get multiplied together to be negative 33. And then the x to the second and x to the first. It says here add the exponents of the common bases. What that means is that if you have common variables, you add the exponents. Remember, this is x to the first right here. When there's an invisible exponent, it's x to the first. And so 2 plus 1 is going to give you x to the third. Put that down there as well, and write it in such a way that, unlike with combining like terms, we're going to say that the results are being multiplied together. So negative 33 times x to the third. Then we do the y part, y to the first and y to the fifth. You add the exponents. 1 plus 5 is y to the sixth. And then finally, what happens with z to the fourth, since there's not another z, again, it is kind of similar to the like term discussion here, where when you don't have another thing to combine with it, similar to with like terms where you didn't have two like terms to combine, you just bring the z to the fourth down with the stuff that's already down here. Okay, and you multiply by what's already down there. Okay, so if you have two variables that are the same, you add the exponents. If you have a variable that doesn't have a second variable that's the same, you then just bring it down and you multiply all the results together, or you say that they're being multiplied. Negative 33 times x to the third times y to the sixth times z to the fourth. Now that's when you multiply a term times another term. However, notice here in this problem, you've still got two brackets being multiplied together, just like you did over here. Nothing in between the brackets, so that is multiplication. But notice that inside of each bracket you have more than one term. Okay, here, because of the minus sign, you got two terms in this bracket. Here you have three terms because of the minus and the plus sign. So what that means when you have two brackets with more than one term inside of each is you take the first term inside of the first bracket and you multiply it by each term in the other bracket here. All of those terms like that. Then when you're done doing the first term in the first bracket, you then move over to the second term in the first bracket and you multiply that by each of the terms in the other brackets, and you keep on doing that until the each term in the first bracket has been multiplied by all the terms in the other one. Okay, so let's try it now. So as you see here, there's 6 multiplications. 6 up here, okay, with the x, and then 6 with the negative y right here. It's a total, I'm sorry, 3 with the x, and 3 with the negative y, for a total of 6. Okay, so let's do the 3 multiplications with the x. We have x, which is 1x. Okay, remember when there's no number visible in front of the x, that means positive 1 or negative 1. But because this is positive, it's going to be positive 1x. So positive 1x times positive 1x squared. We multiply the coefficients. When we're multiplying terms together, we multiply the coefficients. Okay, and then we add the exponents if the variables are the same. So if you have x times x squared, that's the same thing as 1x times 1x squared. You don't need to write this down off to the side if you don't want to. I'm just making sure you understand. 1x times 1x squared, you have 1 times 1 is 1, and then you do the x to the first and x to the second. 1 plus 2 is x to the third. And so that first part right there, the answer is x to the third, which is the same thing as 1x to the third. You don't have to write the 1 if you don't want to. Okay. Then we have 1x times negative 4 xy. Okay, I put a bracket around that because that's what we usually do when you multiply by a negative. Okay, 1 times negative 4. Again, we're doing the coefficients first. 1 times negative 4. All right, and then we have x to the first times x to the first. 1 plus 1 gives you x to the second. Again, those variables are the same, so we add the exponents. And then just like with the z to the fourth in the first problem over here, okay, because of the fact that the y doesn't have another y to multiply by, you just bring that down into the answer, okay, or into the answer. And so negative 4x squared y. So we take that and we put that down here, okay. Now, when you multiply two brackets that have more than one term inside of each bracket, and you get, in this case, 6 different results, however many terms you end up getting, you've got to have pluses and minuses in between them. Okay, so since this was negative, you don't need you do need that minus to be there, I should say. If it had been positive, you'd put the plus there, though. We'll see that coming up here on this next part. In fact, let's do it. 1x times 1y squared. 1 times 1 is 1. Okay, you don't need to write the 1 as long as there's a variable part. Okay, but we do, since it's going to be positive 1, we're going to write plus. You could write the 1 if you want to. Okay, but then we have x times y squared. Okay, let's just go ahead and write it down right here because this is a little bit different. 1x times 1y squared. Okay, remember, since x and y squared, since those two variables do not have another variable that's the same, we just bring that into the answer. We don't do any adding of exponents there. So 1 times 1 is 1, and then the xy squared just goes into the answer. Since it's positive, we put the plus right there. You don't need to write the 1 when it's 1. We have 3 more to do here. We have negative 1y times x squared. Okay, negative 1 times 1 on the coefficients is going to be negative 1. You don't need to write the 1, but you do need to write the minus because it's negative. Then we have x squared times y. We usually write, you don't have to do this, but you usually write it in alphabetical order when you're multiplying terms and you bring down your variables. Okay, so I'm going to bring down x squared and y. Again, you don't try to add any exponents there. You just bring down the x squared and the y, just like we did on this one right here. Okay, because that is, those variables are different. Then we do negative 1 times negative. I'm moving to the next set of terms here. Negative y times negative 4xy. We have negative 1 times negative 4 is positive 4. Okay, I'm running out of space here. And then x doesn't have another x to multiply by in this pair right here, so we just bring that into the answer. And then y times y, that's since those are the same variables, we add the exponents. 1 plus 1 is y to the second. Okay, I'm going to make some room for myself here. Okay, let's move that out of the way. Okay, there we go. And then negative 1 times positive 1 on these last two terms here that we got to do. Negative 1 times positive 1 is negative 1. Again, you don't have to write the 1, but you got to write the negative because it's negative, or the minus because it's negative. Then we have y to the first times y to the second. 1 plus 2 is 3, so we have y to the third. No x this time. Okay, so what we do when we have a polynomial with no parentheses, okay, is it's similar to this problem over here, which again is from a different video, where you just have a polynomial, no parentheses or anything, okay, And you have some like terms though. What you do in this case after you're done multiplying your brackets like this is that you should end up, after you clear out all those parentheses and do all the multiplications, you should end up with a big polynomial with no brackets left. And when that happens, if there are some like terms, we then go ahead and combine those, just like it tells us up here. After multiplying is completely done, combine like terms. But also, just like it's done in this problem, okay, you just combine the like terms, okay, and then you'd have your final answer. We're going to do the same thing in this current problem, okay, x to the third. And by the way, if you look closely to this, all of these terms have the same degree 3. So it doesn't really matter what order you write these in, okay. As it's been mentioned before, usually we write down the final answer in descending order of degree from highest degree to lowest degree. But if they're all the same degree, it's not really a big deal how you do it. So I'm just going to get started with the first term here. X to the third does not have another matching like term right here. This is not it because it's got a different variable even though it has the same exponent. So I'm just going to bring x to the third down, as we always do when it doesn't have a matching like term. Remember, we're in the like term mode right now, you guys. We're done multiplying. So we're back in the using the rules for combining like terms. Okay, speaking of that, these two terms right here are like terms. Okay, second and fourth term. -4 minus 1 is -5. The variable part stays the same when you're combining like terms. Okay, and then we also have a couple more like terms right here. Okay, 1 plus 4 is 5. That's positive 5, so I'm going to say plus 5. And then the xy squared part of the term stays the same. And then finally, the only term we have left is -y to the third. It doesn't have a like term partner to combine with, so we just bring that down. Okay, as we always do in that case when we're combining like terms and there's nothing to combine with it. Okay, so that is what you do when you have a term times another, I'm sorry, not a term, but a bracket with more than one term in it times another bracket with more than one term in it. Speaking of that, I know this problem looks different, this next one, but it's actually the same, because when you have just a single bracket with an exponent 2 on the outside, I'm just talking about when it's on the outside, okay, when there's more than one term inside of the bracket, you got to write this out twice like this. Why do I write it out twice? Because as you guys know, when you take something to the second power, it means you're multiplying it twice. And when you have a bracket next to an exponent, okay, that exponent applies to the entire bracket. So if you have bracket squared, which is what this says, that means the bracket is being multiplied twice. So what it ends up creating is it ends up creating a situation that looks like this, where you have two brackets being multiplied, just like up here, with more than one term inside of each. Now some of you might be wondering, hey, why don't we just square each part here? You know, 3 squared is 9, 3 to the second power, in other words, is 9, x squared is x squared, -4 squared is 16, y squared is y squared, and then we'll be done. Now, you can't do that, though. That is the kind of thing, and that will be discussed in a different video, but that's the kind of thing that you would do if there was just one single term inside of the bracket. This is more than one term. It makes a huge difference. Please don't confuse that, okay? If you had a situation like this, and I won't get into this in too much detail because, again, this is something for a different video. You don't need to worry about it here. But see how there's a single term inside this bracket with the exponent on the outside? In this case, you would apply the exponent on the outside to each part. 3 squared, x squared, y squared squared. That's different. Okay, that's a whole different story. All right, not the same as this problem. Because there's more than one term inside of the bracket, we got to do it this way, where you write out the bracket twice. Twice because of the exponent 2. So because we have more than one term inside of each bracket, and because the brackets are being multiplied, we do the same thing that we did in the last problem. You take the first term in the first bracket, and you multiply by each term in the other bracket.
Okay, so I multiply by both of these. Then you go to the next term in the first bracket and you multiply by each term in the other bracket. Just like we did up here, it's just that we have a few less terms this time because the second bracket doesn't have as many terms to multiply by. Okay, so let's go through it here. 3x times 3x. 3 times 3 is 9. Remember now, don't get caught up in the whole combining like terms thing. Remember, we're multiplying right now. And so x and x is not going to be x. Okay, I'm not done writing this yet. 1 plus 1, since we're multiplying, you've got to add the exponents, and so that would be 9x to the second. Okay, let's keep going here. 3x times negative 4y. 3 times negative 4 is negative 12. And then the x and y just come on down because they don't combine with anything. Negative 4y times 3x. Again, that's going to be negative 4 times 3. And then the x and the y come down. Could you say yx? Yes, but it's better to say xy just because it's what we're used to. It's what we're going to get used to doing here when you're writing out the different variables in a single term. Just talking about a single term here. We usually put them in alphabetical order. And since they're being multiplied, it really doesn't matter theoretically what order it's in. So that's why it could be y. That's why it could be negative 12yx right here instead of negative 12xy. But again, we typically put it in alphabetical order. And then finally, negative 4y times negative 4y. Negative 4 times negative 4 is positive 16. And then y is going to be y squared because we're multiplying and therefore we're adding the exponents. Now, once again, we got rid of the brackets. We did all of our multiplication. We just have a simple polynomial laid out right here with no parentheses or anything. Okay, and it does tell us to combine like terms next up here. And so therefore, we know how to combine like terms when it's just a polynomial with no brackets. We just combine what we can here. Now, I'm actually going to bring this down first. This one does not have anything to combine with. So I'm just going to bring down 9x squared. But then we combine those two terms right there. Negative 12 minus 12 is negative 24. Okay. And then 16y doesn't have anything to combine with it, so we just bring that down. And now we've combined like terms as the directions asked us to do on the last step. Okay. Now this next one here is a little bit different. It's a little bit bigger. Let me make sure you understand what this is here. When you have a term times a bracket times another bracket, that is similar to when you have three things being multiplied together. Let me say that again. Term times bracket times bracket. So that's three things, right? This times this times this. Okay. It's the same thing down here when you have a bracket times a bracket times a bracket. You want to look at that the same way where it's three things being multiplied together. Now I'm going to take you back in time for just a moment. In your younger days doing math, maybe in elementary school or something like that, and they gave you a problem like this. This is completely separate from this problem, but it helps you understand it a little bit. When you did a problem like this for the very first time, your teacher told you to multiply two of these three. This is only assuming if they're all being multiplied. As you can see, because of the multiplication symbols, they're all being multiplied. When they're all being multiplied and you have three of them, you need to do two at a time. It doesn't matter which two you do first. Okay, I could do 2 times 5 first. I could do 3 times 2 first. It doesn't matter. Let me just go ahead and do 3 times 2 first. What you do then is you then take that answer and you multiply it by the last one, but you do not go like this. Do not write that down because it's wrong. You're not going to do 3 times 2 and 3 times 5. That's not how you do it. If you do that, you'll get a different answer, which is wrong. Okay, so when you have three things being multiplied together, you have to do two at a time. Don't touch the third one until you're done multiplying the first two. Okay, this is equal to 30, right? What if I had multiplied 2 times 5 first, gotten that answer and multiplied it by 3, which is the thing you haven't multiplied by yet? Wouldn't that also be equal to 30? 2 times 5 is 10, and then 10 times 3. Okay, so you can see you get the same correct answer either way, but you got to do two at a time. Okay, so let's look at it here. I'm going to go ahead and multiply these two first, and then multiply the answer by that. Now, something that we haven't seen yet is what happens when you have just a single term, whether it's in a bracket or not, being multiplied by a bracket with more than one term in it. You may have heard of the distributive property before. Whether you have it or not, that's okay. The point is that that's the phrase we usually use to describe when we have a single term times a bracket with more than one term in it. What you do is you just multiply the 2x by each of those two terms. And that takes care of these two things being multiplied together. Let's see how that comes out. 2x to the second. X and x gives you x to the second. 2 times 1 is 2. 2 times negative 2 is negative 4. And then the x from the 2x times negative 2, that just comes down here. We still have to multiply by the x squared plus 4. Bring that down. Now, there's something very important I need to add to this. And you're not going to be reminded to do this, such as on a test question or something like that. You need to remember this yourself, okay? Notice that there's 2 terms in that answer I got from the first 2 parts. Unlike over here, when I multiplied, I just got a single term here, 6. So that's different. You didn't need to do anything different there. But because there's 2 terms here, in the answer you got from the first 2 things you multiplied, you have to put a bracket around something that has more, the key thing here, more than one term, as opposed to just a single term. If your answer has more than one term in it, and you still need to multiply that whole thing, which we do, times something else, in this case we still got to multiply by this, you have to bracket that thing that you got from the first 2 terms. That's if there's more than one term. Okay, so you have to remember to bracket that. If you don't bracket it, it's going to look like you're just multiplying the negative 4x times this bracket over here. That's not correct. You got to multiply the whole thing. So let me say it one more time because it's going to be important throughout the semester. When you have something that has more than one term in it and you need to multiply that whole thing by something else, in this case, this right here, you need to bracket that thing that has more than one term in it, okay, before you multiply. Now you can see, now that I've set this up here, you can see it looks similar to this. 2 brackets. They both have more than one term in it. In fact, they both have 2 terms, just like this one. And they're being multiplied because there's nothing in between here. Let's go ahead and multiply it. Remember, we got to finish doing all of our multiplication here, okay? They did ask us to multiply, so we got to finish doing all of our multiplication. So we got to still do this. 2x squared times x squared. 2 times 1 is 2. X squared and x squared is x to the 4th. 2 plus 2 is 4. 2x squared times 4. 2 times 4 is positive 8. The x squared just comes on down. Negative 4x times 1x squared. Negative 4 times 1. X and x squared gives me x to the 3rd. Again, we're multiplying here. We're not combining like terms yet. Negative 4x times 4 is negative 4 times 4 is negative 16, and then the x just comes on down. Now that I have done all of my multiplications and all I have left is just this polynomial, just a bunch of terms being added and subtracted together, okay, and there's no brackets left, that's when they want you to, as it says up here, that's when they want you to combine like terms. Okay, are there any like terms here though? Notice how it says, if necessary, combine like terms. Well, check this out here. This is kind of rare, but it does happen sometimes. There are no like terms here once we do all of our multiplications and get rid of all of our parentheses, okay? And so that's why I'm going to stop right there. In fact, I don't even need to write that equal sign right there. Okay, so that happens sometimes. Now, should I reorder this because of the fact that this has a higher degree than this one? You don't have to, okay? You don't always have to do that. There are times, and I'll make sure to explain that as needed, okay, as we do different videos and everything, as we do different lessons. But in this case, it's not necessary. So you could reorder this. In fact, I'll go ahead and just do that just for practice. You don't have to. When you have just a polynomial with no parentheses or anything, just a bunch of terms being added and subtracted, if you want to reorder the terms, okay, just make sure that you still have pluses and minuses in between the terms when you reorder them, and make sure that the terms still have the same number in front of each, including the same sign. So I want to put this one next. Okay, don't just move the 4, move the entire term, including the minus sign. Okay, same thing here. Don't just move the 8, move the plus. Okay, and then right there. Now, the only exception to having to move the plus or the minus would be if you move something to the very front and it was plus, you don't need to write that. Remember that when we have the first term is positive, you don't need to write that plus there. Okay, you could essentially if you really wanted to, but you don't have to. Okay. In the same respect, if I was to move this term, which doesn't have a plus in it right now, to some other location, like the second term or the third term, that you would then have to put a plus in front of it because this is positive. So there is theoretically a plus in front of this. You just don't need to write it when it's first. Okay, so just wanted to give you some details on that in case you do some reordering of terms in the future. Okay, so both of these are okay. Now, what I'd like you to do right now is to try these 3 problems down below. Okay, you can see that 3 and 4 are similar to B and C. This one's a little bit different than problem D, but the only difference is that you still want to multiply the first 2 right there. Get that answer. You're going to need to put a bracket around the answer because it's going to have more than one term, and then multiply by that. Okay, so go ahead and try that. Turn the video off for just a moment, and then we'll take a look at the answers when you turn the video back on. Okay, let's see how these answers come out right here. Okay, I'm going to zoom out a little bit. There we go. There we go. So in this first one, again, remember when you got more than one term in the bracket and it's being squared, you got to write it out like this first. Okay, with the brackets being multiplied twice. Then when you multiply it out, we're going to have a total of 4 multiplications like this. And that. And these are the 4 terms that you get. Now that I've cleared out all the parentheses, I've done all my multiplications, and I just have a normal polynomial with no parentheses, I now combine like terms. And that leads to this term in the middle. The first and last term just come down into the answer because they don't combine with anything. In number 4, we have to multiply xy by each of these terms here. We have to do the same thing with plus 3, excuse me. Okay, and that gives, sorry about that, hold on. We got to multiply by those 3 terms right there. There we go. And that leads to these 6 terms right here. Once again, the parentheses are gone. All the multiplications have been completed. And so now we have a normal polynomial. It's a big one, but it's still a normal polynomial with no parentheses, just a bunch of terms being added and subtracted together with pluses and minuses in between. So we combine like terms, and we get this right here. Okay. Number 5. Okay. We first of all want to multiply the first 2 brackets. We do that, and we get this right here. You could go ahead and combine like terms before you multiply by x squared plus 5 right here. You don't have to. I went ahead and did that. Either way, the answer is going to come out the same. So I combine like terms. I remember to put a bracket around it because it's even after combining like terms, I still have more than one term here. And I have to multiply by this thing. So as we said a few minutes ago, you got to bracket that. So this is the final setup right here. We got to multiply these 2 things. So you multiply x squared times each of these 2 terms. We then go to negative x and we multiply by each of these 2 terms. Again, each term in this bracket, one at a time, gets multiplied by both x squared and by plus 5. And again, we do that also with negative 2 times these 2 terms. We get these 6 terms right here. Finally, after all that, we have a normal polynomial. Parentheses have been cleared out. Multiplications have been done. We combine like terms and we get what you see right here. Okay, these two terms were the only two terms that were like terms. I went ahead and put them in descending order of degree, even though I didn't have to, but like I've said before, we typically do that. Okay, so that finishes up our discussion on multiplying terms and terms and polynomials. What we need to talk about right now, as I go back and get my original piece of paper here that doesn't have the answers on it yet, so that we can do them together, is dividing polynomials. And there's two different types of dividing polynomials. Sometimes you divide by like a big polynomial down here, okay, that has more than one term. But we're just going to talk about when you divide by. In other words, the second thing in the division, okay, the thing you're dividing by is just going to be a single term, okay? How do you do that? How do you do it when the thing on top here has more than one term? You can see that there's 4 terms up here. But the thing you're dividing by down below, that is just a single term. Here's what you do. Okay, you're going to divide all 4 of these terms one at a time by this term. Okay, but we got to be very careful in how we do that. Okay, let's go through it carefully here. The signs are important as well. As you may remember, dividing is very similar to multiplication when it comes to signs. If the signs are the same, it's going to be positive. Positive divided by positive is positive. It's also true that negative divided by negative is also going to be positive. But if you're dividing by 2 different terms, such as negative divided by positive, for example, the answer is going to be negative. So in this first part here, and we're going to be real careful about this. Please do this. Please don't try to go too fast here. Okay, there's multiple reasons for this, but I want you to write this out as a fraction here, because we're going to want to make sure that we put this in lowest terms correctly and everything. So I'm going to divide these 2 things, but the reason why there's no negative in front of this, if it was negative there would be, and I'll get into that in a minute when we do have a negative answer here. But because this is positive divided by positive, there's going to be, again, you could put a plus in front of here, but similar to regular polynomials, okay, this is the first fraction, and since it's positive, you don't need to put a plus in front of it because it's the first one and it's positive. Okay, but it is positive because it's positive divided by positive. Same thing with the next one. Okay, positive divided by positive. I'm going to bring down these 2 terms. Now, what do I do with that plus right there? It all depends on what the answer is going to be. Because it's positive divided by positive, it's going to be a positive answer. When that happens, you guys, again, very similar to polynomials. Okay, because this is not the first fraction, okay, and because it's positive, you do need to bring down a plus in front of that. Again, you don't need the plus in front of the first one because it's the first one. But because this is not the first one, you do need the plus. If this had been a negative answer, you'd put a minus in front. Okay, but you don't need to, in fact, please don't, because that's going to potentially mess things up. Don't put the pluses or minuses inside of the fractions, okay? Let the pluses and minuses tell you what the answer is going to be, either positive or negative. If it's positive, put a plus in front, unless it's the first fraction. If it's negative, then put a minus in front. Okay, speaking of negative, here we have negative divided by positive, negative 40x divided by 5x. And so again, don't put the negative on the inside. Don't ever put the pluses or minuses on the inside. They just tell you what the sign's going to be. Because negative divided by positive is negative, we're going to put a minus right there because it's negative. And same thing here, negative 10 divided by 5x. Again, don't put the minus inside the fraction. Just say 10 divided by 5x for the fraction. And because it's negative divided by positive equal to negative, we're going to put a minus in front of that. Now we've got it set up. So what do we do with all of this? Okay. I want to really make something clear here, okay, that when you have a polynomial divided by just a single term, Okay, no parentheses or anything. That's sometimes different. But when you have just a then that's a discussion for a different video when you got the brackets. But if you have just a single polynomial, no brackets, and a single term down here, okay, if there is more than one term in either the top or the bottom, obviously there's more than one term here on the top, do not cancel anything yet. Do not cancel anything. Let me say that one more time. If there's no brackets in either the top or the bottom, okay, not talking about those types of problems. That's, again, a separate video. But if you got just a polynomial on the top and the bottom, and either the top or the bottom is more than one term, do not cancel. Do not cancel the 25 and the 5. Don't try to reduce the 50 and the 5. That's what I'm talking about here. When I say cancel, I'm talking about reducing into lowest terms. But notice that what I said there, I said that if the top or bottom has more than one term. Notice that each one of these fractions, now that I've separated them into different parts, each one of these fractions, you guys, has one term in both the top and bottom. One term divided by one term divided by one term. When you have one term in the top and bottom of a fraction, you are allowed to reduce it, okay, without having to do anything special. You can just start reducing. Let's take a look at this first example here. Okay, and one other thing I want to point out to make sure that you remember this. Don't ever cross cancel when there's a plus or minus in between two fractions. If this was multiplication, that would be different. Then you can cross cancel in many cases. All right, but this is not the case here. Here the fractions are separated by pluses and minuses, not multiplication. So don't cross cancel. You can only cancel within the same fraction. I can't cancel, for example, the 25 with this 5 over here because I'm crossing from one fraction to the next with a plus in between, not multiplication. But I can reduce the 25 and the 5 because they're in the same fraction. So stay within the same fraction. Put each one of these fractions in lowest terms. Let me explain to you how to do that if you don't remember. What you do is you start out with the coefficients. You take the largest number that divides into 25 and 5 evenly. Okay, the number 5 divides into 25 and 5 evenly, and there's no number bigger than that that would do that. And so 25 divided by 5 is 5. 5 divided by 5 is 1. And now you've reduced those coefficients, but you still need to do x3 and x. Now, how do you do it when you have, again, a single term divided by a single term and you have the same letter? It has to be the same letter, the same variable. If it is, though, you subtract the exponents. You don't add them. You add the exponents when you're multiplying, right? We just learned that up here, right? Up here. But when you're dividing, you subtract the exponents. But there's one other thing you need to consider as well. We'll get into that. But we do subtract, okay? Do we do 3 minus 1 or do we do 1 minus 3? Okay, what order do we do it in? Well, we always do the bigger one minus the smaller one. So even if the 3 was down here, you still would do that. It's just the way where you put the answer would be different. We'll get into that here as we go along. So 3 minus 1 is 2, right? And so what you do is you then ask the question, well, where do I put the x to the second? You're still gonna keep the x, but now it's gonna be x to the second. What you do is when you subtract the bigger exponent minus the smaller exponent, you always put the answer where the bigger exponent was originally located. So the x to the second would go in the same place that the x to the third was originally located. And then automatically, you guys, wherever the smaller exponent was, you put a 1 there. It's always a 1. Okay? So subtract the exponents, bigger minus smaller every time. Put the answer where the bigger exponent originally was. Put a 1 where the smaller exponent was originally. What do we now have here? We now have 5 times x squared, because this is still multiplication here. It's just that the 25 and the x to the third got replaced by these two things. So it's still 5 times x squared. Now on the bottom we have 1 times 1. 1 times 1 is 1. We could write 5x squared times, we could write 5x squared divided by 1, because there is the division symbol here. But you don't have to, because when you divide by 1, you don't need to write it. Isn't 5x squared divided by 1 the same thing as just 5x squared? Just like if I said, hey, what's 6 divided by 1? Isn't that just 6 without the 1? Okay, isn't 6 divided by 1 the same thing as just 6? No need to write the 1. That's the point, you guys. When the 1 is on the bottom, when it's equal to 1, the whole thing on the bottom, you don't need to write it. Now, if the top is equal to 1, that's different. You can't say that 1/3 is equal to 3. No. Okay, I'm just talking about when the bottom is 1. Okay, that's the case here. So, hey, we did the first part. We just need to do the other 3 fractions exactly the same way. Okay, so 50 and 5. Go ahead and bring down the plus, by the way. 50 and 5. The biggest number that divides in both of those is 5. So 50 divided by 5 is 10. 5 divided by 5 is 1. And then once again, what do we do with the exponents? We say 2 minus 1, which we're allowed to do the exponents because the x's are the same letter. 2 minus 1 is 1. We put that answer, x to the first, we put that wherever the bigger exponent was originally. We can just say x, because that's the same thing as x to the first. And then you always put a 1 where the smaller exponent was. Now you might be thinking, is it always going to be 1 and 1 on the bottom? No. Almost always, but not always. So don't assume that. So we end up with 10 times x on the top. 1 times 1 on the bottom, which is 1, so you don't need to write the 1 underneath it like we talked about in the last part there. Bring down the minus in between, just like we brought down the plus in between before. And then 40 and 5, what's the largest number that divides into both of those? It would be 8. I'm sorry, I got a little bit ahead of myself there. We divide by 5, we get 8 over 1. And then here's the thing. Notice that both of these exponents are the same. When they're both the same, you don't need to do the subtraction. They just cancel. They just become 1 and 1. If the exponents are the same, you don't need to do the subtraction thing. You can just say 1 and 1. Okay, just like if you had, for example, again, separate problem here. If I had 3 divided by 3, that's the same thing as 1 divided by 1. Okay, it's equal to 1 either way. Okay, when they're the same like that. So it's the same thing with x and x, because 1 divided by 1 is 1. It makes sense that 1 and 1 is going to be the same thing as x and x. So we end up with 8 times 1 on the top, which is 8. 1 on the bottom, and so you don't need to write it. Bring down that minus. Now here's where things get a little bit different. They get a little bit different. Okay. Once again, 10 and 5, you do the largest number that divides into both. 10 divided by 5 is 2. 5 divided by 5 is 1. But here's where it's different. The x does not have another x up above it. It's kind of like with combining like terms again. If x does not have anything to cancel with, just leave it where it's at. Don't just put it anywhere you want. You have to leave it where it originally was. So if it had been on top, you'd keep it on the top. But because it's on the bottom in this case, you keep it there. So what we end up with is we end up with 2 on the top. Now notice we don't have just a 1 on the bottom anymore. We have 1 times x, not 1 times 1. So 1 times x is x, and we get that. Okay. Please understand, you guys, this fraction bar only applies to this fraction right here. These 2 or these 3 answers all have invisible 1s underneath them, not x. And so don't let this fraction bar go all the way across here. Keep it right here in just this last part here. And so we did it. We figured out what all 4 of those were. So 2 things you have to do. You break it up into different fractions. You reduce each fraction to lowest terms, and then you're done. One additional thing we need to do here beyond what we just learned, and that's the fact that in this problem, it's not written like a fraction. But I want to make sure you understand that when you have a bracket divided by a bracket, not times a bracket, not plus or minus, this is the first time we've seen a division symbol in between 2 brackets. What we do in that case is it is similar to this right here. And you can actually get rid of the brackets if you write it this way. It's okay. You can make it into a fraction by taking the first fraction bar. I'm sorry, the first bracket, not fraction bar. and you put it above the fraction bar that you're going to create. So bracket divided by bracket means the first thing inside of the first bracket goes on top. The thing inside of the second bracket goes on the bottom every time. Okay? Now it looks just like the last problem where you got a polynomial with more than one term divided by a single term. So we're going to do exactly the same thing. The details are a little bit differently, so listen closely. But basically the process is the same. Okay? However many terms there are on top, there's 4 terms up here, right? That means we're going to have 4 fractions again. If there had been 3 terms on top, we'd have 3 fractions. We're going to divide each term by the term below the fraction bar. Now, because we're dividing by a negative this time, be careful. It's going to be a little bit different. Positive divided by negative is negative. And remember, don't put any positives or negatives inside of your fraction bars. Put them on the outside according to what the sign of the answer is. So I'm going to write it like that. Okay, remember, if the first answer is negative, you got to put the minus. It's just that if it was positive, you don't need to write the plus. But when it's negative, you got to write the negative. It does make a difference. Next one here, we have negative divided by negative is positive. We then write out the 2 terms right there, not including the sign, which has already been taken care of in front of the fraction. Then we have what? We then have positive divided by negative is negative, so I'm going to put a minus in front there, bring the 2 terms into the fraction, like this. And then finally we have negative divided by negative is positive, so I'm going to put the plus right there, like that. And then just like in the last problem, after you break it up into different fractions, you then put each fraction into lowest terms, exactly the same way we did in the last problem. Once again, what's the largest number that divides evenly into 25 and 5? It's not always going to be 5 on every problem. It's just worked out that way in these 2 problems. Okay, 25 and 5, we divide both of those by 5. We get 5 and 1. Okay, since both the top and bottom have x in it, we do 8 minus 5. Don't do 5 minus 8. Do 8 minus 5. It's going to be 3, of course, so that's going to be x to the 3rd. These both cancel out. As always, we put the larger one, we put the answer where the larger exponent was located originally. We put a 1 where the smaller exponent was originally. And don't forget to bring down that minus there as well. That's separate. But minus 5x to the 3rd over 1 times 1, so you don't need to write the 1, as we talked about in the last problem. Bring down your plus. 50 and 5, we can divide both of those by 5. Again, make sure you divide by the largest number that will divide evenly into 50 and 5. That just happens to be 5 here. 10 and 1. 7 minus 5 gives me x to the 2nd, so I'm going to put x to the 2nd where the larger exponent was, 1 where the smaller exponent was. 10x squared over 1 times 1 gives me 10x squared. Let's keep going. We bring down the minus. This is a different situation right here. 3 and 5, they're the only number, which would then make it the biggest number, that goes evenly into 3 and 5 would be 1. But if you divide both of these numbers by 1, it's not going to change them. Anytime you divide by 1, it doesn't change it, right? So 3 and 5, we're just going to keep those the way they are. In other words, they're already in lowest terms. Okay? But x, we can do that. We can always do x if both the top and bottom have an x there, as long as it's single term. You have a single term on the top and bottom. So 6 minus 5 is x to the 1st. So we're going to say x to the 1st where the bigger exponent was. 1 down here. What do we get? We get 3 times x on the top. But we can't ignore the fraction bar this time because on the bottom we do not have 1 times 1 this time. We have 5 times 1. Let me make that fit right there. 3x over 5. There we go. 3x over 5. All right, almost ran out of room there. Bring down the plus. Okay, 40 and 5, we divide both of those by 5, and we get 8 over 1. And once again, just like we saw in the last problem, if the exponents and the variables are both the same, okay, just like we saw with x to the first and x to the first, it just becomes, you don't need to do that subtraction thing, you can just say 1 and 1. What do we get here on this last part? 8 times 1 over 1 times 1. That would be 8 over 1, which is 8. Okay? So we did it. We put each fraction in lowest terms after we broke it up into different fractions. Okay, so that is how you divide a polynomial by just a single term. Okay? So that concludes our video on multiplying and dividing terms in polynomials.